Tautomerism is a process in which a double bond and a proton change places. Starting here with the enol on the left, the proton is moved to the alpha carbon next to the carbonyl, and the pi bond has moved from between two carbons to between carbon and oxygen. The acid-catalyzed tautomerism process will be described first. In the presence of acid, the alkene portion of the enol picks up a proton to give a heteroatom stabilized carbocation. This is a Markov-Nikov type process, since it is going through the more stable of the possible carbocation intermediates. Putting the positive charge next to the electron-rich oxygen allows for sharing of one of the oxygen's lone pairs, as shown in the two resonance structures. The tautomerism process is completed by water from the solvent removing a proton from the oxonium ion to reveal the ketone product. In this case, the ketone is the thermodynamically favored isomer, so it will be favored in the equilibrium. The proton transfer to water also reproduces hydronium ion, so the process is catalytic in acid. In summary, the conversion of an enol to a ketone through tautomerism is catalyzed by acid. The acid adds to the alkene to give a resonance-stabilized carbocation, which is then deprotonated to reveal the more stable ketone tautomer. At high pH, for example in the presence of hydroxide, the enol and ketone interconvert to give an equilibrium mixture in which the ketone is again favored. The mechanism begins with hydroxide deprotonating the alcohol group to give the conjugate base. Since the alkoxide is attached to the alkene, the charge can delocalize between the oxygen and alpha carbon groups. The former representation is described as an enolate depiction, and the latter is an alpha carb anion contributor. Proton transfer from the water solvent to the alpha carbon then produces the ketone tautomer and also regenerates an equivalent of the hydroxide base. Since the reactive base initiates proton transfer in the first step and is regenerated in the last step, it is serving as a catalyst in the tautomerism process. Overall, tautomerism between enols and carbonyl species may be catalyzed by base. Again, the equilibrium composition of the mixture of isomers will typically favor the carbonyl-containing species.